or continued. Is that working? Or?
Yeah.
So we're going to take a look at the function f of x equals x squared plus 2. Our first task is going to be to make a graph of it. And we're going to do it like we've been doing with our chart of our xy points. I know yesterday we did more than 3 points to help us see what the inverse was going to do. Today we're doing more than 3 points because our function is raised to a power. So yesterday's graph was a straight line. Will this graph be a straight line? No, because it's x squared, it's going to be a parabola. So if we plug in for x 0, what are we going to get? 2. If we plug in 1, 3. If we plug in 2, 6. Okay, we did the easier ones first. How about negative 1? Because so if we square negative 1, it becomes positive 1 plus 2 is 3. And negative 2 will become 6. So if we make our graph of this function, we'll have, and I will point out that there is a scratch here on the board for those of you that aren't used to my room and may wonder what that is. So negative 2, 6, negative 1, 3, 0, 2, 1, 3, and 2, 6. So we have a parabola looking like so. And is this graph a function? Is this the graph of a function? Yeah. What has to be true for a graph to be a function? It has to pass what test? Vertical line test. If we draw a vertical line, is there anywhere that we can draw a vertical line that's going to hit this graph more than once? No, all vertical lines will only hit it once. So it is a function because it passes the vertical line test. Now, from yesterday, do you remember how we find the inverse? How do we find the inverse of a function? What do we do if we have the chart?
You switch it.
We switch the x and y's. So for the inverse, we're going to take and put the y's in the first column, the x's in the second, reverse all the orders on the ordered pairs. So I believe we will get the purple chart. And we can then take those points and graph them on our same set of axes. And we will get the purple graph. Now, shape-wise, should the purple graph be the same shape as the white one? Yes, it's going to be off a little bit, you're right, because of my drawing of it on the board, but it should look just like the white one. Now think back to geometry. You had some different transformations from geometry. Do you remember the 3 different ways you could move objects in geometry? Rotation, reflection. Translation. So if you remember, a rotation turns it, a reflection flips it, and a translation just slides it. Could we do any of those 3 to the white one to get the purple one? Okay, we could do a rotation. Is there anything else we could do? How about a reflection? Could we, if you had this, you've got it on sheets of paper in your notebook, right? Is there any way you could fold your notebook paper to put the purple one and the white one so that they were on top of each other? How might you be able to fold it? Anybody meeting with any success? Getting their purple one on top of their white one? Yes? Where's your folded line? It's going down at a diagonal like that. Does that match up with some of you that were able to visualize the fold? If you couldn't come up with it now that they gave you a clue, are you possibly seeing how that might work and get the purple on top of the white? Could you give me an equation for this line? It went through what, the point 0, 0? I believe 1, 1, 2, 2, 3, 3, etc. What would its equation be? What's its y-intercept? Liz?
0.
0, because it goes through the origin. What's its slope? 1, because it's going up 1 over 1. So what's an equation look like with a y-intercept of 0 and a slope of 1? Y equals x. So the inverse is the reflection of the original function over the line y equals x. Now our purple graph, is our purple parabola a function? No? Why not? So the this one is not a function because it does not pass the vertical line test. So that means we could draw a vertical line somewhere and it would hit this graph more than once. So it is not a function. Now, what we want to think of, it would be nice to kind of know ahead, just looking at the white one, that the purple one isn't going to be a function. If we look at this line here, the vertical line that I put through the purple, if we were to reflect that back over the line y equals x, what would this line look like if we reflected it? it would become a horizontal line. So it would look something like this. This would be the reflection of the vertical line over y equals x. And it's now what type of a line? This is vertical. This is horizontal. And notice that horizontal line hits the original graph in 2 places. So if a horizontal line hits the original graph in more than 1 point, then the inverse will not be a function. And we refer to that as the horizontal line test. It's kind of the counterpart to the vertical line test. So if a horizontal line hits it more than the original more than once, its inverse will not be a function. Now, let's think in terms of finding the inverse algebraically. So from yesterday, what do you remember about finding the inverse algebraically? How do we go about doing it? What's the first step? Allison?
Switch the x and y.
Switch the x and y. So our function will become x equals y squared plus 2. Are we okay there? Then, now we need to do what? Subtract 2 on both sides because we are trying to ultimately, where are we going?
Solve for y.
We're trying to solve for y. So if we subtract 2, we'll have x minus 2 equals y squared. How are we going to undo squaring something? Take the square root, and whenever we take the square root, what do we have to remember?
Plus or minus.
Plus or minus. Now, if you went to enter this into your calculator, can you in one line put y equals plus or minus the square root of x? Is there a plus or minus button on your calculator? No, there is not. So let's get your calculators out. And in y1, let's put the original function, x squared plus 2. So it should, and we're going to do a zoom 6 for the window. So do you have a graph that resembles our white one? Yes? Okay, now in y sub 2, graph the square root of x minus 2. Are we okay entering that all right on our calculators? Second x squared gives you the radical sign.